Section 6.2 is titled Solving Systems by Substitution. We worked with solving systems by graphing, so this is now our second method to solving a system of equations. So let's remember the different types of solutions we can have to a system of equations. One of three things can happen. We can have intersecting lines, where we have exactly one solution. They intersect at one place. We could have parallel lines, where they'll never intersect, so we have no solutions. And you'll want to remember this little example, 10 equals 3. It's something similar to when you're solving an equation and you get no solution. Or we could be talking about the same line. Oftentimes you could have two equations that look different, but they are actually equations of the same line. They may be multiples of one another, in which case we would have infinitely many solutions because those two equations would intersect at every possible point on the line. And an example here, if you're solving, would be 10 equals 10. So let's look at how to solve by substitution. I do want you to write these steps down, and even though while you're writing them down it's probably going to seem confusing, it's always best when we go to the examples. But first you're going to look at either equation, and you're looking for a variable that has a coefficient of 1. There may be more than one variable in more than one equation that has a coefficient of 1, so you just pick which one you want to work with first. It won't matter. But then you're going to solve that equation for that variable. So if your x has a variable or has a coefficient of 1, which means there won't be a number written in front of it, then you want to solve that equation for x. Once you have that equation, step 2, solve for that variable, you're going to substitute the resulting expression, so whatever x equals, into the second equation. Then you're going to have an equation that has one variable, but it's going to show up a couple times, so you're going to solve the equation for that variable by combining like terms and then solving. You're going to plug your answer back into either of the original equations to solve for the second variable, and then write your answer as an ordered pair. Just like solving systems by graphing, your answer is an ordered pair. Same thing here, solving by substitution. Your answer is an ordered pair. So let's just look at some examples. Solve by substitution. Number 1, we have y equals 2x minus 4. And the second equation is 2x minus 2y equals 8. So what we are looking for is we are looking for the equation that has a variable with a coefficient of 1. You can see the first equation, we have a coefficient of 1 for our y. We have a 2 in front of the x, a 2 in front of this x, and a negative 2 in front of that y. So we only have one spot here where we have the coefficient of 1. What we want to do next, though, is solve the equation for that variable. So I want to solve the first equation for y, but if you look at it, it's already solved for y. So then we want to take whatever y equals, in this case y equals 2x minus 4, and I want to plug it in to the y of the second equation. So if y equals all of this mess, then I need to take that mess and plug it into the bottom equation. And now I'm going to rewrite the equation. 2x, coming from here, minus 2, but now instead of y, I'm substituting all of this in, because this is equal to y. We discovered that here, y equals all of that. So we're going to plug in the 2x minus 4 in for y, and then I still have the equals 8. And now you'll see I have an equation that only has one variable, which means I can solve for that variable. So I need to distribute, so I get 2x minus 4x plus 8. Please pay attention to your signs. A negative 2 times a negative 4 is a positive 8, equals 8. 2x minus 4x, that's a negative 2x, plus 8 equals 8. I've combined like terms. Now I'm going to subtract 8 to the other side. I get negative 2x equals 0. Divide both sides by negative 2. Then I get that x equals 0. Well, now I have the first half of my answer. Remember, our answer gets written as an ordered pair, x, y. So the x comes first, so it's 0, comma, something. These lines intersect at the ordered pair 0, something. Well, now I need to figure out where that goes. Where does the x go? I need to plug it back in. If x equals 0, I can plug it back into either equation, either there or here, and I could solve for y. Now, the first equation actually happens to be a lot easier when you're doing substitution because it's already solved for y, so all I need to do is plug in the 0 and chug out an answer. So let's see what we get. I get that y equals, I'm plugging it into 2x minus 4. So I'm plugging it in for x because it's what x equals. Don't plug it in for y. 0 minus 4. 2 times 0 is 0. 0 minus 4. And I get y equals negative 4. So the ordered pair where the two lines intersect, or the solution to the system, is 0, negative 4. Now I know that there's a lot of, that seems like a lot of arithmetic or algebra work, and it is, but it's another method besides graphing. So let's solve by substitution. Here we have 2x plus y equals 7, and we have 3x minus y equals 8. Hopefully you're pointing out where's the variable with the coefficient of 1. And it's the y in the first equation. The second equation does have a 1 in front of it, but it is a negative 1. So while you could solve the second equation for that y, it's going to be much easier to solve the first equation because it is a positive 1 already in front of it. So let's do that. We have 2x plus y equals 7. Remember, the first step is solving one of the equations for one of the variables. So we're solving the top equation for y by subtracting 2x to the other side. Make sure you understand why you're subtracting it. Because it was positive, we want to do the opposite. So now we have y equals negative 2x plus 7. So we're going to take what y equals and we are going to substitute it into the other equation for y. Remember, all of this equals y, so I need to substitute it in for y. So that gives me 3x minus, but instead of y, I'm writing all of this. And you want to make sure you're using parentheses because there are a lot of negative signs and things need distributed. And it equals 8. So I have 3x minus a negative 2x plus 7, and it equals 8. And I need to distribute this negative sign through. Remember, that's actually a negative 1. So when we multiply everything by negative 1, we get 2x, then we get negative 7, and it equals 8. So now I'm going to combine like terms. 5x minus 7 equals 8. I'm going to add 7 to both sides. 5x equals 15. Dividing both sides by 5, and we get that x equals 3. So for our answer, it's an ordered pair, 3, comma, something. The question is now, where do I put that 3 to find y? Well, it can go a lot of places. You can plug it back in here, you can plug it back in here, but the easiest place is actually to go back here because this equation is already solved for y. So we have y equals negative 2x plus 7. We're going to plug the 3 in there. So negative 2 times 3 plus 7. We get y equals negative 6 plus 7, or y equals 1. So the ordered pair, or the solution to the system, is 3, 1. Okay, let's look at another example. 3x plus y equals 4. 2x minus y equals 6. Hopefully you're saying that this equation, the first one, is a little easier to solve for that y since it's positive. So let's do that first. So I'm going to subtract 3x from both sides. And I'm going to get y equals negative 3x plus 4. Remember, these are not like terms, so they cannot be combined. Now I'm going to take that equals y and plug it into the other equation. Always make sure you're plugging it into the second equation or the equation you have not worked with yet. Don't plug it back into the first equation. So now we get 2x minus, and I'm plugging in a negative 3x plus 4, and it equals 6. So again, I want to distribute that negative 1 through. 2x plus 3x minus 4. Notice how my signs change. So I get 5x minus 4 equals 6. Add 4 to both sides. 5x equals 10. Divide by 5 and we get x equals 2. So we have half of our answer. And it won't always be the x you find first. Sometimes you'll find the y first. It just depends on which equation is set up for you to solve for the variable in the beginning. Notice I solved it for y, so x was actually the variable or the part of the ordered pair I found first. But now I want to plug that 2, and remember, where do I plug it back into? Well, I can plug it into the first equation. I could plug it in here. I could plug it in here. It's actually easiest to plug it in down there, since that equation is already solved for y. So it's negative 3x plus 4. And we're plugging in our answer of a 2 in for x. So we get y equals negative 6 plus 4, or y equals negative 2. So we have an answer here of 2, negative 2. That's the solution to the system, or that's where the lines intersect. If you'd like to pause the video and try one on your own if you haven't done so yet, number 4 is set up kind of nicely because we have a coefficient of 1 in front of the x and we have a coefficient of 1 in front of the y. So you could actually solve either one of those equations first for x or for y. Let's go ahead and solve for x on this one since we haven't done it that way yet. We've had all of our other ones solved for y. So I'm going to subtract the y to the other side. That's going to give me x equals negative y. So I'm going to take that negative y. This time, though, it equals x, so I need to plug it in for x of the second equation. Don't plug this in for y. It doesn't equal y. It equals x. The part you circle, whatever it's equal to, that's what you plug it in for. So we get 5 times negative y plus 2y equals negative 3. 5 times a negative y would be a negative 5y plus 2y equals negative 3. Negative 5y plus 2y is a negative 3y. Divide both sides by negative 3. And we get that y equals positive 1. So we have the first half of our answer, but remember it's the y coordinate of the ordered pair. So our answer is going to be something, comma, y. And now I need to plug that 1 in somewhere so that I can find x. Remember, you could plug it in here for y or here for y, but the easiest place would be to plug it in right there. So we have x equals negative y, and I'm plugging in a 1 for y. So you can see that x equals negative 1. So the solution to the system is negative 1, 1. Okay, number 5, we have 6x minus 2y equals 4 and 3x plus y equals 4. So here you can see the second equation has the variable with the coefficient of 1, so we're going to subtract 3x from both sides. That's going to give us y equals negative 3x plus 4. And I'm going to circle that, and I'm going to plug it in for y on the first equation, because the second one's the one I solved, so I don't want to plug it back in there. I want to plug it back in up top. So that gives me 6x minus 2 times everything I want to plug in there, negative 3x plus 4, and it equals 4. So that gives me 6x plus 6x minus 8 equals 4. Remember, when you distribute, a negative times a negative is a positive, and a negative times a positive is a negative. So we get 12x minus 8 equals 4. We're going to add 8 to both sides, and we get 12x equals 12. Divide both sides by 12, and we get x equals 1. So again, we have the first half of our answer. It's going to be 1 comma something. I need to plug that 1 in for x somewhere. I could go here, I could go here, but it's easiest to go there. So I have y equals negative 3x plus 4, and I'm plugging the 1 in. Negative 3 times 1 plus 4. That gives me y equals negative 3 plus 4, or y equals 1. So the solution to this system is 1, 1. Very last example here, I think we have 2x minus y equals 7, and we have 4x minus 2y equals 14. So here we don't actually have a variable that has a coefficient of a 1 in front of it, but the closest we have is the first equation that has a variable y that has a negative 1 in front of it. So we're going to go ahead and solve that first equation for y. So I still want to subtract 2x to the other side. But here you have to remember to bring down the negative y. And it equals negative 2x plus 7. But now we need to divide everything by negative 1. And it's all three pieces, all three parts. So we get y equals 2x minus 7. So notice what happened there. We had to divide by that negative 1. If there were any other number in front, let's say a 2 or a 4, then you would divide everything by 2 or 4. But here it's a negative 1, so we need to divide everything by negative 1. So now we solved the first equation for y. So we want to plug that in for y of the second equation. So we have 4x minus 2 times 2x minus 7, and it equals 14. We want to distribute 4x minus 4x plus 14 equals 14. Well, 4x minus 4x, those cancel, and I'm left with 14 equals 14. So here's one of the first instances where we've lost our variable. So I'm going to take you all the way back to one of the beginning slides that shows the two special cases where we could have parallel lines or we could have lines that are the same. And here's where we want to focus. Do we have an answer that's true, a number that equals itself, or do we have an answer that's not true? This is true, in which case it's infinitely many solutions. However, this is false, in which case it'd be no solutions. We'd be dealing with parallel lines. So it's either the same line or it's parallel, and our answer is either no solutions or infinitely many. So let's go back to the problem again. And here it is. And we have something that's true. So these would be the same line, and our answer here would be infinitely many solutions. And this is what I'd be looking for on a test or a quiz or in your homework, is infinitely many solutions. You don't have to write true and you don't have to write same line, but infinitely many solutions. And actually, if you look at those two equations back in the beginning, if we were to multiply this top equation by 2, we would get 4x minus 2y equals 14. And then you can see we are dealing with the same exact line. So the second equation was just a multiple of the first one. Still the same line, though, if you were to graph them. In class, we will work on worksheet 6-2.